Okay, now you guys try 16, but try this with 40 degrees, not 45. Otherwise, it's just an isosceles right triangle. All right, so find the unknown, which is the height of the building. So this is the unknown right here. Okay, go ahead. All right, so we use tangent again. Not always, if we were given the hypotenuse or something like that, or they asked for the hypotenuse, then we'd have to maybe use sine or cosine. But again, in relation to this angle, this is opposite, this is adjacent, so tangent fits this definition. So tan 40 degrees equals x over 10. Now, I like to stick with just the cross multiplying, because whether the unknown is in the bottom or it's in the top, cross multiplying takes care of it either way. So I just like to give you one method. Okay, so I do x times 1 equals 10 times tan 40. Don't multiply 10 times the angle, make it 400 degrees. That would be a mistake. You're just going to punch it in like this, 10 times tangent of 40 degrees, because tangent 40 is just some decimal. Okay, so what I mean by that is if I just looked at tan 40 by itself, it's equal to this. Okay, so I put the 10 in front of my calculator or do it this way and now hit times 10. And just moves the decimal over, so we get 8.39 meters. You can always check your answer. 8.39 meters, tan 40 is equal to what? The 0.839? Well, throw in 8.39 right here and divide it by 10 and see what you get. It's going to be the same decimal, 0.839, okay? Okay, just want to look at one more here. Let's look at 17. I want you to read through it, and then I'll help you with the sketch on this one. And we're going to find the angle this time. Go ahead and read it first. All right, so we got this little airplane here on the runway. It's getting ready to take off. It's building far in the distance, hopefully, that it needs to make sure it clears. So they're asking for what is this angle that it needs to take at a minimum to make sure it clears the height of that building, right? Obviously, we don't want to run into it. And so this is creating a right triangle scenario. We can assume buildings are built at 90 degrees or very, very close to it, right? I mean, they're good contractors and architects. That's 90 degrees. So here's our kind of right triangle situation. All right, they're actually asking for what angle we need to fly at. So we'll go over that here in just a moment, how we do that. Airplane takes off 200 yards in front of this building. So this is 200 yards here. And they said the height is 80 feet. Oh, they didn't keep the same units, did they? All right, so we'll do a little conversion. So this is 80 feet. And why don't we take this yards and multiply it by 3, right? There's 3 feet in each yard. So if we multiply this by 3, we have 600 feet. Okay? Okay, so again, we still got to ask ourselves, how are these two sides related to the angle? It is opposite and adjacent again. So we'd set up this ratio right here. Tangents of the angle of elevation, theta, equals 80 over 60. The units cancel out, so you don't necessarily have to write them down if you don't want to. Okay, there's not really an algebra step for this one. You just got to know there's a calculator step for this one. To find the angle, this is what you do. At least write this part down so you know. We find the angle by doing what's called an inverse operation. This is called inverse tan when you have that little -1 there. So inverse tan of whatever's on that right side. So I'll take a little bit of getting used to. You have the two sides, find the angle. This is what you do. Okay. So it's second. Hit the second button on the calculator and then hit tangent. So second tan produces the inverse tan. And then put in our ratio of 80 over 600. Or if you reduce the fraction, whatever, it doesn't matter. It's going to work. Okay, so 7.59 degrees is the angle of elevation. That's the minimum one, right? You don't want to make it close. You probably want to round up to like an 8 degree to make sure that they do that. But let's just be accurate with this problem and say 7.59 for now, okay? So theta is 7.59 degrees, but higher, right? We want to make sure we're above that. maybe I'll just say above. So theta above 7.6 degrees. How about that? So we clear the building. Okay, that's it for today. And then tomorrow we'll work a little bit more on creating these sketches. These can be hard for a lot of different scenarios. Today, for the most part, they'll give you the sketches to work with in your practice. Find those unknowns. And then the first couple problems we did too as well.